Course 3, Lesson 57. We are looking at scientific notation once more, but instead of big numbers, we're looking at small numbers with our operations. So, when we talk about our laws of exponents, remember when we're multiplying, we are really adding the exponents if we have the same base. So, 10 squared times 10 to the third, we get 10 to the fifth. 10 to the negative third times 10 to the negative fourth, we add negative 3 and negative 4 to get 10 to the negative seventh. 10 to the negative fifth times 10 to the eighth, adding those together, we get 10 to the third. And when we're dividing, we are really subtracting the exponents. So 10 to the third divided by 10, well, this is 10 to the first. So 3 minus 1 is 10 squared. 10 to the negative eighth divided by 10 to the negative second, 10 to the negative eighth minus a negative 2, we actually need to add the opposite. So 10 to the negative eighth minus a negative 2, well, those negative is positive, so negative 8 plus 2 is 10 to the negative sixth. And then 10 to the negative ninth divided by 10 to the seventh, we're going to do 10 to the negative ninth minus 7. So we're going farther into the negatives, and we get 10 to the negative 16th. What this helps us do is be able to multiply and divide with scientific notation. So when multiplying two numbers in scientific notation, we multiply the first two numbers and then multiply the powers. So we get 2 times 4 and 10 squared times 10 to the fifth. So we get 8 times 10 to the seventh. And then with this situation, if a sheet of notebook paper is 0.01 centimeters thick, how tall is a stack of 2,500 sheets of notebook paper? Well, we can put 0.01 in scientific notation and 2,500 in scientific notation to get 1 times 10 to the negative second times 2.5 times 10 to the third. And so we can multiply 1 times 2.5 and then multiply 10 to the negative second times 10 to the third. And we end up getting 2.5 times 10 to the first. But if we're talking about this logically, we would probably rather just say 25 centimeters. That's a lot easier to understand. All right, express the result in scientific notation. So let's look at these 4 examples. 2.4 times 2, and then 10 to the negative 6 times 10 to the negative second. Add all of that up, and we get 4.8 times 10 to the negative eighth. Second one, we get 4 times 5, which is 20, times 10 to the negative 10th, but this is not in scientific notation. So we need to divide by 10 here, which means we need to add a 10, we need to divide by 10. Okay, so, or you can think about it as moving back. Here, let me erase this for a second. We need to move our decimal back. So starting here, let's see if my pen is going to work today. There we go. Maybe. So we put our decimal and we move it back once, so we move our exponent up. So in order to do that, we end up with 2 times 10 to the negative ninth. Okay, or we divide by 10 here, so we need to add another 10 here, going closer to 0 in this case. And then we divide. We get 1.2 times 10 to the, well, negative 8 minus the negative 2 is going to give us that negative 6. And similarly, 4 divided by 5 is 0.8 times 10 to the negative 6. So we need to borrow one of the 10s to get us to 8. And now we have 1 less 10, which is actually to the negative 7th. Okay. Let's try a couple more, or I'll leave these up here, and then you can pause the video and try them out on your own. And then you will see that we get 3.6 times 10 to the negative third. We get 15 times 10 to the negative seventh, but that's not in scientific notation. So we divide by 10, and we have 1.5 times 10 to the negative sixth. We divide and we get 1.6 times 10 to the negative 5th. And, well, we have 0.4 times 10 to the negative 4th. Remember, negative 8 minus a negative 4 is plus 4. And we borrow a 10 to get it to 4 times 10 to the negative 5th. Now let's look at some of these more situational ideas to decide, do we need to multiply or divide, and how can we do that? Well, in 1998, the population of the world was 5.9 billion. In the same year, the population of the U.S. was 2.7 times 10 to the 7th. What percent of the world's population was the U.S. population? Well, in order to find the percent, we can do the part divided by the whole. Well, the part that we have is 2.7 times 10 to the 7th, and the whole is the 5.9 billion, which we can show in scientific notation as 5.9 times 10 to the 9th. Now, we need to divide, okay? But in order to get this into percent, we're going to end up with a decimal here, a small decimal, that we need to then put into percent by multiplying by 100, which I'm going to show as 10 squared. Well, in order to do this, we need to divide our numbers first, which I am going to put to the nearest tenth. Okay, nearest 100th, and we get 0.46 times 10 to the negative 2nd, but to put it into percentage, we're going to multiply by 10 to the 2nd, which means right here we really get 10 to the 0 power, which is just 1. So we have 0.46%. Okay, so when we divide, we get that 0.46 times 10 to the negative 2nd, and to put it into a percentage, we multiply by that 100, which cancels out that those powers that we had of 10, and we end up with just 0.46%. Less than half a percentage point was the U.S. population versus the world population in 1998. Write 5 times 10 to the negative 5th in standard form. Now remember, when we have that negative exponent, we're going to take my 5 and move that decimal. We're dividing by 5 powers of 10. So we go back 1, 2, 3, 4, 5. Now all of those loops we're going to add in 0. So we get 0.00005. Or I believe that is, let's see, tenths, hundredths, thousandth, 10,000, hundredth, thousandths. So 500 thousandths. And then 2.5 times 10 to the negative 2nd, we're going to move back that decimal twice to get 0.025. Okay. The diameter of a red blood cell is about that many meters, really small. Write that number in scientific notation. So we do 7 times 10 to the, well, it's a really small number, so we're going to have a negative exponent. And we need that 1, 2, 3, 4, 5, 6, minus 6. Okay, interesting idea here. If the lightning strikes a mile away, the sound reaches us in about 5 seconds, but the light reaches us in about 5 millionths of a second. Right? 5 millionths in scientific notation. Well, 5 millionths as a decimal is, let's see, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, and millionths. Okay, so 5 millionths. So to put this into scientific notation, we will do 5 times 10 to the, well, 1, 2, 3, 4, 5, 6. So minus 6. Now, if we wanted to know how many times faster that is compared to hearing the lightning, what we would need to do is we would need to take that 5 seconds, okay, so 5 times 10 to the 0 power seconds, and divide it by how fast this one is, 5 times 10 to the negative 6th seconds. And we do 5 divided by 5 is 1, times 10 to the 0 minus a negative 6 is really just a 6. That means that seeing it in this scenario is 1,000,000 times faster than hearing it. Okay, and last example here. A nanometer is 10 to the negative 9th meters. Write that in standard form. Well, really what we have here is 1 times 10 to the negative 9th. So I'm going to take that 1 and move the decimal 9 times backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and all of those zeros. Well, I hope this is helpful for your homework and for studying.